An AI agent can search the web, call an API, compare results, and write a report in seconds. But ask it to buy one tiny piece of data from a new provider and the whole process can fall apart. It may need an account, an API key, a subscription, and a credit card form designed for a human. X402 is an attempt to remove that bottleneck. It lets a server respond to an ordinary web request by saying, in a machine-readable way, "This costs money." The agent can authorize the payment, retry the request, and receive the data. Potentially, all of that happens without a human touching a checkout page. On July 14, 2026, the X402 Foundation became operational under Linux Foundation governance. Coinbase completed its contribution of the protocol, and the Foundation announced 40 participating organizations. The list includes Visa, MasterCard, American Express, Circle, AWS, Google, Cloudflare, Coinbase, Stripe, Shopify, Ripple, Solana Foundation, and Stellar Development Foundation. That sounds like X402 suddenly launched on July 14th, but there is an important distinction. The protocol already existed and was being used. What changed was its governance and industry backing. It moved from a Coinbase-originated project into a neutral foundation where payment companies, cloud providers, stablecoin businesses, blockchains, and commerce platforms can help shape the standard. So what is the actual problem? Every time an app loads a page or requests data, it usually communicates through HTTP. The server answers with a status code. 200 means the request worked. 404 means the resource was not found. 500 means the server had a problem. HTTP also has a code called 402, payment required. It has existed for decades, but the web never settled on one widely used payment flow around it. A server could say payment was required, but there was no universal language for explaining the price, accepted payment method, destination, and proof that payment had been authorized. That is the gap X402 tries to fill. Imagine an AI research agent needs a weather forecast from a paid API. First, the agent sends a normal request for the forecast. The server does not return the data. It returns a 402 response with payment requirements. Those instructions can describe the price, the accepted token or payment scheme, the network, and the address that should receive the money. The agent's X402 software reads those instructions and checks them against its rules. Maybe the request costs 1 cent in USDC, and the agent is allowed to spend up to 10 cents on approved data providers. If the request passes those checks, the agent's wallet creates a signed payment authorization. The important word is authorization. The AI model itself does not magically control a blockchain account. A wallet system holds or manages the signing key. The agent asks that system to approve a specific payment under whatever permissions the owner configured. The request is then sent again with a payment signature attached. The server verifies that authorization, settles the payment directly or through a facilitator, and returns the forecast. A final payment response can include the settlement result. From the user's perspective, the agent asked for data and received it. Underneath, there were 2 HTTP requests, a wallet signature, payment verification, blockchain settlement, and a response containing the purchased resource. If you enjoy explanations that make these invisible crypto mechanisms easier to see, consider subscribing. Now, let's look more closely at what each component is actually doing. The wallet belongs on the buyer's side. It stores the stablecoins or controls access to them, signs payment payloads, and authorizes transfers. It might be a self-managed wallet with its own private key, or a managed wallet service that signs according to programmed policies. The stablecoin is the unit being transferred. Stablecoins are useful here because API providers generally want predictable prices. Charging 1 cent is much easier when the payment asset is intended to track the US dollar than when its value can move sharply between the request and settlement. USDC has been a major early example, although X402 is designed to support multiple tokens and networks. The blockchain records or settles the value transfer. X402 is not itself a blockchain, and it does not have a native X402 coin. Think of it as a payment language carried inside HTTP. Different payment rails can sit underneath that language. Then there is the facilitator. A facilitator is an optional service that checks the signed payload and submits the transaction for settlement on behalf of the seller. This means a weather API company does not necessarily need to run blockchain infrastructure, monitor nodes, and build verification logic for every supported network. The facilitator does not need to hold the buyer's money. It can receive a signed authorization, verify that it matches the seller's requirements, execute the permitted transaction, and report the result. A seller can use a managed facilitator, operate its own, or handle verification and settlement directly. For very small or frequent payments, recording every single request as a separate blockchain transaction may become inefficient. X402 can support different payment schemes, including fixed price payments, usage-based charges, and batch settlement. In a batch model, value can be locked or deposited once, while individual usage authorizations happen off-chain and are redeemed together later. That reduces on-chain activity, but introduces more accounting logic and reliance on the batch settlement mechanism. Where do cards fit into this? The best way to understand x402 is to separate the message from the payment rail. The 402 response communicates what payment is required. The payment scheme explains how the buyer can satisfy it. Today, stablecoins are the clearest machine-native use case because a wallet can create a cryptographic authorization in software. But the standard is intended to be extensible. A facilitator could connect an x402 request to card infrastructure, bank payments, or other systems. That does not mean every Visa or MasterCard card automatically works with every x402 endpoint today. Membership in the foundation is not the same as universal deployment. It means those organizations now have a place to help define how these systems could interoperate. That neutral governance matters because payment standards become more useful as more parties accept the same rules. An API provider is less likely to adopt a protocol tied permanently to one exchange, one stablecoin, or one blockchain. Buyers also do not want a separate wallet integration and payment format for every website. Linux Foundation governance gives x402 a better chance of being treated as shared infrastructure rather than a Coinbase feature. Support from cloud companies matters because agents and APIs run on cloud infrastructure. Support from Stripe, Adyen, Fiserv, and card networks matters because merchants already depend on their fraud controls, compliance systems, refunds, reporting, and settlement tools. Support from Circle and blockchain organizations matters because stablecoin payments require reliable assets, wallets, networks, and liquidity. Still, an impressive membership list does not guarantee that x402 becomes a universal standard. The biggest challenge may be safe authorization. If an agent can spend money, what exactly is it allowed to buy? A broad wallet permission could let a compromised agent, malicious plugin, or prompt injection drain funds through thousands of individually small requests. Real deployments need limits per transaction, per day, per service, and per category. They also need allow lists, anomaly detection, approval thresholds, and an emergency stop. Duplicate requests are another danger. Networks fail, servers time out, agents retry. Without an idempotency system that recognizes the same payment attempt, a client could be charged twice. x402 includes mechanisms that can help identify and deduplicate payments, but services still need to implement them correctly. Privacy is not automatic either. A user may avoid creating an account with the API provider, but public blockchain activity can reveal wallet addresses, payment times, amounts, and repeated relationships between buyers and sellers. A wallet address is pseudonymous, not necessarily anonymous. Facilitators, stablecoin issuers, infrastructure providers, and regulated payment companies may also collect information for security or compliance. Refunds create a different problem. Card payments come with mature dispute and chargeback processes. Blockchain transfers are usually much harder to reverse. If an agent pays for bad data, receives a broken response, or buys something the user did not intend, the HTTP payment may have worked perfectly while the commercial transaction still failed. A universal payment standard also needs practical answers for receipts, refunds, service guarantees, fraud, and customer support. Stablecoins bring their own dependencies. They can lose their target value, face issuer restrictions, or be frozen at the contract level. Blockchains can become congested or experience outages. Facilitators can go offline. Payment confirmation may arrive after the API request times out. If a system supports many chains and tokens, sellers also inherit more technical complexity. And x402 does not make every API truly permissionless. A service may still require identity checks, licensing restrictions, regional controls, or an API key for reasons unrelated to payment. Paying for access is not the same as being legally or technically authorized to receive the resource. The core idea, though, is powerful. Instead of forcing software to imitate a human at checkout, x402 puts a payment negotiation inside the same request and response pattern software already uses. The server states its price. The wallet authorizes value. A payment rail settles it. The server releases the resource. That could make tiny pay-per-use services more practical and let agents purchase data, compute, content, or specialized tools only when needed. It could also create machines that spend too quickly, reveal too much, or make make decisions their owners struggle to reverse. The July 14th launch does not prove that x402 has won. It shows that a serious group of payment, technology, and blockchain organizations believes machine-to-machine commerce needs a common language. The next test is whether they can turn that language into something secure, interoperable, and boring enough for the wider internet to trust. What would you let an AI agent pay for automatically, and where would you always require human approval? Share your answer in the comments, along with any crypto or AI payment topic you want explained next.